Right, class. So last time we were looking at the addition formulae, and now we're going to be looking at the double angle formulae, which come from the addition formulae. So here, on the previous page, we were looking at sine of A plus B, which is sine A cos B plus cos A sine B. Now let's say, instead of A plus B, I said A plus A, which would give a sine of 2A. So here it's saying if I replaced the B with A plus A rather than B, you'd get sine 2A. Now sine 2A, sine of A plus A, is sine A cos A plus cos A sine A, which is 2 sine A cos A. Okay. If we did the same with cos of A plus A, so you'd get cos of 2A, you'd get cos squared minus sine squared, because that's cos A minus sine A sine A. Now from here, if you've got that first identity, you can derive the other two. So here, I also know from one of the first identities I gave you that sine squared is 1 minus cos squared. Okay, so if I replace this sine squared here with 1 minus cos squared, I would get the second identity. I'll just show you. So here I've got cos squared A from there, minus sine squared A, which is 1 minus cos squared. Cos squared minus minus makes a plus. So cos squared plus cos squared gives you 2 cos squared minus 1. And that's that identity there. Let's say instead of replacing the sine squared, I replace the cos squared. So I know that cos squared is 1 minus sine squared. So I'm going to replace that cos squared with 1 minus sine squared. And if I do that in that identity, I'll get 1 minus sine squared minus sine squared. That's that one there. Which gives you 1 minus 2 sine squared. Okay, so for the cos 2A identity, you've actually got 3 different ones, okay, which makes it a tad trickier. So you've got sine 2A is 2 sine A cos A. You've got cos 2A, you've got 3 different forms. And similarly, if I did something similar for A plus A, so tan of 2A, you would get this identity here. Now, we don't tend to use this very often. We tend to use these much more often. And this one is always tricky to use because there's 3 different forms. Okay, so I'm going to have a look at that first example. Okay, so I'm looking at page 174 of Pure Book 2. I'm looking at the double angle examples. I just thought I'd work through these with you, just because this is a difficult topic and I'd rather take it slow. Okay, so it says use the double angle formula to write each of the following as a single trig ratio. So if you've got a piece of paper, can you get these examples down as well? Don't just watch me do it, actually do it with me. Okay, so the first one says cos squared 50 minus sine squared 50. Can you write that as a single trig ratio? Okay, so just come off this. Well, I know that cos squared minus sine squared is the cos 2A double angle formula. Okay, so here cos squared minus sine squared, if I say A here is 50 degrees, then this here is cos squared A minus sine squared A. And then this here is the same as cos of 2A, which is equal to cos of 2 times 50, which is cos of 100. Okay, so I've written it as a single trig ratio. Okay, the next one says, can you rewrite this one, 2 tan pi by 6 over 1 minus tan squared pi by 6? Can you write that as a single trig ratio? Okay, so that looks like it's the double angle formula for tan. So I'm just looking at that over here. And it looks like A is pi by 6. So here I'm just going to write that A is pi by 6. So that's 2 tan A over 1 minus tan squared A. So this will be the equivalent of tan of 2A. 2A being 2 lots of pi by 6, which is pi by 3, tan of pi by 3. Done. Single trig ratio. Okay. The last one, 4 sine 70 over sec 70. Well, sec, you should know, is the same as 1 over cos 70. Okay. Oh, sorry, not 1 over cos 70. That's 1 over cos 70, like that. Okay, so when you are dividing, so here, I'm just going to rewrite that. So that is the same as cos 70. Okay, so if you're not sure, let me just show you. So 1 divided by 1 over cos 70. When you divide by a fraction, you flip it and multiply, like that, which is why I've got cos 70 there. So I've got 4 sine 70 times cos 70. Again, this looks really similar to a double angle formula. It's got a sine timesing a cos. So here, sine timesing a cos, where you've got the same angles, is that top one there, sine 2 raised 2 sine a cos a. Okay, so here, if I rewrite this as 2 times 2 sine 70 cos 70, that is 2 times sine of 2a, which is 2 times 70, which is 2 times sine of 140 degrees. Okay, done. All right, let's have a look at the next one. So the next example is example 8, which is, just go back to the actual example, that one there. Okay, so it says, given that x is 3 sine theta, and y is 3 minus 4 cos 2 theta, eliminate theta and express y in terms of x. Okay, so they want me to get rid of theta, essentially. They want me to link the two equations together, but eliminate theta as well, okay, and have y equals something. So here, I'm going to start with the more complicated equation, which is the second one, and I'm going to manipulate it and see if I can make it look like something with just x's in it. All right, so I'm going to start here. So I've got 3 minus 4 cos 2 theta. Okay, as you know, there's 3 different forms of cos 2 theta. I'm going to use the one that has only got sines in it because I have that x over 3 is sine. So of the 3 different forms, I'll just put it over here. You've got it in your book there as well. I have got that cos 2a is 1 minus 2 sine squared a. So I'm going to replace that with 1 minus 2 sine squared a. 1 minus 2 sine squared. In this case, it's theta, like that. I'm going to tidy up. 3 minus 4, minus and a minus makes a plus 8 sine squared theta. 3 minus 4 is minus 1, like that. And sine theta is x over 3. So if I square that, x squared over 9 is sine squared. So I might as well put that in there. Oops. Okay, so I've got y is minus 1 plus 8 times x squared over 9. And that's it. I have got an equation in terms of x, y equals something in terms of x. Okay, done. All right. And I think I'll probably do one more, example 9 from the notes. So it says, given that, so here it is, I'm looking at that, given that cos x is 3/4 and that x is between 180 and 360, find the exact value of sine 2x and tan 2x. Okay, right. So, well, if I've got cos x is 3/4, I can draw my triangle like that. There's x. Cos is adjacent over hypotenuse, adjacent over hypotenuse. Oops. Then this one here, off the top of my head, is going to be, well, I don't know off the top of my head. I'd have to do 4 squared minus 3 squared and then square root it, which would give me 16 take 9, which is, what's that, 7? Root 7? So this side here is root 7. And then I have got that sine x is opposite over hypotenuse. And I have got tan x is opposite over adjacent, root 7 over 3. Okay, I need to decide what the signs on these are though, because it has told me that x is between 180 and 360. Okay, so between 180 and 360, I'm just going to draw my sine graph, which looks like that. There's 180, there's 360. So between 180 and 360, sine is quite clearly negative, so I need to put minus there. Let me just draw my tan graph. I'm going to draw my cos graph as well, actually, because I think I might need that. There's 180, there's 270, there's 360. Okay, sorry, I'm blocking your view there. Okay, the reason why I've drawn the cos graph here is that they have given me that x is between 180 and 360, but cos x is quite clearly positive. So if it's between 180 and 360 and cos x is positive, in actual fact, x must be between 270 and 360 rather than just between 180 and 360. Okay, so I know it's in that region there. Doesn't really make an issue with the sine x, but I think when I draw my tan x graph, which looks like that, it's not brilliant, doesn't have to be, just to give me a bit of a picture of what this looks like. There it is, there's 360, 270, 180, 90. You can see that here, between 270 and 360, tan is quite clearly negative, so I'm just going to put a minus there. Okay, so I've got all those values, and then I'm going to go back to sine 2x. So sine 2x is 2 sine x cos x. It's the double angle identity. And I'm just going to replace the sine x with this value here. And cos x is 3/4, like that. And then you can just tidy it up and work it out, which it looks to be is minus, don't actually know what it equals, minus 3√7 over, I don't know, something, 16? I don't know. It says it's equal to minus √7 over 4. Okay, so you can simplify that yourself. I don't have well, I have got a calculator, but I'm just running out of time here. So the next one, it said tan x. I've got to work out what tan x. I've got tan x, haven't I? So I just need to work out tan 2x, which is 2 tan x. Again, I'm using the double angle identity. This is not given to you, 1 minus tan squared a, or tan squared x, so you do have to learn it. So that would be 2 times minus √7 over 3 all over 1 minus √7 over 3 squared. And then you type that into your calculator, do a little bit of tidying, and you'll get their answer, which looks to be as minus 3 over 7, or √7, minus 3 over √7. There we go. Okay.